Welcome back to Westwood Engineering. Today we're talking about some combined circuits. On your screen, you're going to see problem 1 from your set. You're also going to see Ohm's law, basic Ohm's law. V equals I times R. I is voltage divided by resistance, and resistance is voltage divided by current. So let's get rolling. Look at this circuit right here, and what you're going to notice is where my cursor is flashing. You've got R2 and R3. These two elements are in parallel, but they're part of what we call a combined circuit. So I've got a series element, R1, flowing into a parallel element, R2, R3, back into a series element, R4. So what we need to do is calculate the equivalent resistance of the resistor R2, R3. You'll see that I've given you the formula in order to do that. So let's get started on the basic math on this. So we look at R2 and R3, our resistance equivalent, and I'm going to call that R23. And I'll just go subscript R23, is equivalent to 1 over 20 ohms plus 1 over 30 ohms. Now you can go through and do the fractions, or you can type it into your calculator. What you're going to end up finding here, and I'll do the fraction for you real quick. You don't have to do this every time, but as I do this fraction, what you're going to see is my common denominator. I'll use a common denominator of 60. So this becomes 3/60ths, and this becomes 2/60ths, and that's going to combine to be 1 over 5 over 60, which is then going to solve as 60 divided by 5 ohms, which is equal to 12 ohms. So I ask you to write that down right here, 12 ohms, or type that in. Now we can redraw that circuit, which is the next problem. Okay, now we're on part B of that same problem, and what we've done is we've calculated what this equivalent resistor is here, and I'm just going to write in that, sorry about that, I got to make my layer active. You'll see that I've got 12 ohms right there. So now we've got an equivalent circuit, and this is just a series circuit. So what I can do is I can find my resistance total is going to be equal to R1 plus the equivalent resistor R2, 3 plus R4. When I do that, pretty simple, 13 ohms plus 12 ohms plus 25 ohms equals to 50 ohms. Now the real question here is I ask you for the total current also. So I'll write this in, 50 ohms. This now becomes a circuit that looks something like this. So I've got a 50 ohm total resistance, and I've got a 10 volt source. I'm looking for my I total going through here. So from Ohm's law, I equals V divided by R. That will be 10 volts divided by 50 ohms, or 0.2 amps, and that's also equal to 200 milliamps. So that's how we find the solution to this next problem. So we're 200 milliamps or 0.2 amps. Either answer is acceptable. Just remember, when we solve these combined circuits, we need to basically convert the total circuit either into all parallel or all series. And then we have a methodology to solve that. Okay, so now we're up to our next part of this problem, which is part C. And to do part C, we have to remember that I've already solved for my total current, and that's equal to 0.2 amps. Now, if we look at how our current flows, it goes into the circuit. Here's my I total. It's then going to branch out and break into two different currents here. And this is going to be the current through resistor 2 and the current through resistor 3. It then recombines, and this is my total current also. So with that information, I can go through and I can compute V1 and V4 pretty easily. So remember from Ohm's law, V equals IR. So V1 is going to equal to my current, 0.2 amps, times the resistance R1, which is 13 ohms. That's going to equal to 2.6 volts. Now V2, I'll do that one in purple here. V2 is going to equal to that same current, total current, 0.2 amps, because it split as it went through these two resistors, and then it recombined, times the resistance R4, which is 25 ohms. That's going to equal to 5 volts. Now we have to go back to Kirchhoff's voltage law. And Kirchhoff's voltage law says that the sum of the voltages across the series circuit add up to be the source voltage of 10 volts. So you can see that V1 up here, I've got 2.6 volts. V2, I've got 5 volts. Well, what's left here has to be 10 volts minus 2.6 volt drop minus the 5 volts. And that's going to equal to 2.4 volts. Now, because it is parallel, this branch, you're now going to notice that V3 and V2 are equal. And I've written that up here for you. So let's fill out our answer sheet. So a quick recap, V1 we compute by taking the total current times the resistance. That ends up being 2.6 volts. V4, total current times resistance of 25 ohms. That ends up being 5 volts. V2 and V3 we arrive at by using Kirchhoff's voltage law, which says that Vt is equal to V1 plus V2, which is equal to V3 plus V4. Or I could write this another one and say V1 plus V3, because it's the same thing, plus V4. So I found this by solving and saying that this is equal to 2.4 volts. That's it for the first problem. Okay, so we've pretty much solved this problem, and I'm going to write in what we've arrived at so far. So what we've arrived at so far in blue is we have arrived that V1 is 2.6 volts. Sorry. So V1 is 2.6 volts. V4 was 5 volts. And V2 and V3 are 2.4 volts each. So now we have to solve and say what's I2 and I3. Now there's a couple things going on here. We said that we've got a total current running through this circuit of 200 milliamps, or 0.2 amps right here. That's going to split off into I1, or I2 rather, and then also into I3. It's going to recombine back into that 0.2 amps in the bottom of the circuit. I'll make that decimal a little bit bigger. So I can solve this any number of ways, but what I can see here is that 0.2 amps has to equal to I2 plus I3. We know that because the current only has those two paths to go. The other thing we know is that my voltage is equal to my current times my resistance, so I can solve for current by going I is equal to V divided by R. So I've got two different solutions here. So let's first solve for I2. And I2 is going to be V2, which was 2.4 volts, divided by the resistance, 20 ohms. That's going to equal to 0.12 amps. Now I can use the same Ohm's law, and I can say that I3 is going to equal to that same 2.4 volts, except now I'm divided by 30 ohms. And that's going to equal to 0.08 amps. Now that's an easy way to solve it. I could also have said that 0.2 amps equals to 0.12 amps when I solve for I2 plus I3. If I did that, I would see that I3 for this alternate solution also equals 0.08 amps. So there we have it. Now, a couple of takeaways from this that are not necessarily obvious. Sorry, I'm writing this in purple instead of, or magenta rather, instead of red. But look at this voltage here, or the way that the current split. And I'm going to draw this out a little larger just for an extra learning point here. And I had my 0.2 amps coming in. And then it split and it went through a resistor that's 20 ohms. And it also split and went through a resistor that was 30 ohms and then recombined down here at the bottom. Now remember the definition of resistance. Resistance is a force that is inhibiting the flow of electrons. So this has more resistance to the electrons. So I should expect less current in this branch than I get in R2. So when I look at my answer, I always want to check that for reasonableness and say, hey, did R2 have more current going through it? Yes, it did. Now, interestingly enough, it's the proportion. It's the proportion. So 20 and 30. So if you look at I3, sorry, I just accidentally scrolled up. If you look at I3, you're going to actually see that, holy smokes, this is 50% less than I2. Guess what? R2 is 50% less than R3. So that direct linear relationship. So check your work. I2 plus I3 does equal 0.2 amps. Now let's look at question number 2. And this basically takes the lessons that we've learned so far about creating an equivalent circuit, and this is your chance to apply them. So looking at this circuit, what I have is I've got a parallel element, and I'll circle this parallel element in green. So I've got a parallel element right here amidst a series circuit. So I want to find a resistance equivalent to this, and I'm going to call this resistor R2, R3. So when I look at this and I draw it out, I can replace this with a single resistor, can't I? And that's R2, 3. So the formula to do that again is 1 over R2, which is 25 ohms, plus 1 over R3, which is 25 ohms. So I've made this math pretty easy just to make it so that it's simple for you. That's going to equal to 1 over 2 over 25, which is going to equal 25 divided by 2. That's going to equal to 12.5 ohms. So let me redraw my circuit now. And I'll redraw my circuit in blue. So what I've got is a 10-volt source coming through a 10 ohm resistor, going through the equivalent, this is R2, 3, which is 12 ohms. Sorry, 12.5 ohms. I'm just going to scratch that out, put it over here. 12.5 ohms. And then going through another 10 ohm and another 25 ohm. There's my equivalent circuit. Now this is a series circuit. What we learned about series circuit is RT equals R1 plus R2 plus, and in this instance, it's going to be R2, 3 plus R4 plus R5. Super quick, we've got 10, 22.5, 32.5, 57.5 ohms. And that is just 10 ohms plus 12.5 ohms plus 10 ohms plus 25 ohms. Okay, so that's our first answer here. Let me put that in red for you. So this ends up being 57.5 ohms. Now my total current, if this is my total resistance, I know that my I total is equal to V total, Ohm's law, divided by R total. That's going to equal to 10 volts divided by 57.5 ohms. So whipping out my handy dandy calculator, you'll see 10 divided by 57.5, 0.173913. So where's the logical rounding point here? We're just going to go down to 174 milliamps, okay? Or 0.174 amps. That equals to 0.17, sorry about that, 4 amps, or 174 milliamps. Now, could I solve for the voltage drop here? Sure. There? Sure. There? Sure. So I could go through and solve the rest of this, but I don't have you do that. It's 0.174 amps, or 174 milliamps. Either one is the correct answer. So that's how we do our combined circuits. Remember, the overall strategy is to look at the circuit and then break it down and make it either all a total series circuit or a total parallel circuit by combining and reconfiguring the circuit elements. Typically, it's easier to do a complete series circuit versus a complete parallel circuit. But you can look at it for yourself and make that judgment each time. Remember those basics of Ohm's law. V equals I times R. I equals V divided by R. And R equals V divided by I. Kirchhoff's current law. Sum of the currents in a parallel branch equals the source current. And Kirchhoff's voltage law. Sum of the voltage drops across a series circuit equals the source voltage. If you can remember those 4 things, you'll solve all these circuits easily. Thanks for watching.